Hello everyone, I'm Beau, and I'm here to report about the findings from the bomb calorimeter experiment that Group 1 conducted. The group leader was Madeline and the other members are Dalton and Connor. So a quick overview of the experiment. A par oxygen bomb calorimeter was used to measure the energy in the form of heat that was dissipated from two different samples. The first sample was benzoic acid, which was used to find the thermal capacitance of the calorimeter. And with this thermal capacitance, we were able to find the heat from the unknown fuel sample. So as far as equations go, we used one, which was from the first law of thermodynamics. And I talked about thermal capacitance earlier, that's the MCV value. And the goal is to calculate the heat of combustion of the unknown substance. So for benzoic acid, this was our results. As you can see, it's not very continuous, but for the sake of my calculations, I used that first portion, which gave us a delta T of a little over 2 degrees Celsius. The mass of the benzoic acid sample was 0.99 grams, and the length of the wire left over after the experiment was 5 centimeters. And for the unknown substance, I did calculations including and excluding this peak right here. So that would be for 2.83 degrees Celsius and 1.2 degrees Celsius. The mass of the unknown substance was 0.95 grams, and the length of the wire left over was 7 centimeters. So for the thermal capacitance calculation, we used MCV equals Q over delta T. The Q of the benzoic acid was given on the container, which was 6,318 calories per gram. And once we took into account that it was 0.99 grams, we got 6,254 calories. And for the wire, it's 2.3 calories per centimeter. And once we accounted for the 5 centimeters that was left over, it was 11.5 calories. So the total Q value, just sum those together, and we divided that by the delta T, which was a little over 2, and we got a thermal capacitance of the system of about 3,100 calories per degree Celsius. So for heat of combustion of the unknown substance, we used that thermal capacitance and multiplied it by the change in temperature. So I did that for the 2.83 and the 1.2 degrees Celsius, and I got about 9.3 calories per gram for the larger temperature change and about 3.9 calories per gram for the smaller temperature change. The reason that it's not in the thousands is because I converted from big calorie uppercase C to, from little calorie lowercase c to the uppercase C, which is just a factor of 1,000. So when comparing that to the results from group 2, our thermal capacitance was fairly similar, but for the unknown heat of combustion, for the unknown sample, it's hard to compare those just because they were different samples. Theirs was, I think, Sour Patch Kids, and ours was Ike and Ike's. But using the average of the thermal capacitance, I was able to get even closer to what the actual calorie count is for Mike and Ike, which I'm going to talk about on this next slide. So the original value that I calculated for was 3.92 calories per gram for the miconite, but using that mean value that came from group 1 and group 2, I was able to get 3.496 calories per gram. And when comparing that to the actual nutritional facts label of the miconite, which I got that calorie per gram by going to see what the serving size was and how many calories was in that serving size, I was able to get an error of about 0.1%, which was, I was very happy with that. It was very close. And the original error based on our original calculations, not including that mean, was about 12%, which is still pretty good. So when comparing that to other substances, micanites have about that 3.5 calories per gram, and coal has about 2 calories per gram, which I thought it was interesting that they contained similar amounts of energy, and gasoline contains about 3 times the energy of a miconite. So In conclusion, possible sources of error may have been, since we were kind of trying to do the experiment quickly, we did not let the tank cool down to room temperature after the first trial, so the second trial may have been affected by that. And also, when weighing the substance and measuring the length of the leftover wire, that could have played a role just because it was hard to get a perfect measurement on that wire, and the scale was a little finicky at first, but we seemed to figure that out. But using the average thermal capacitance resulted in a much more reliable value, and I'm interested to see what the next group's able to do with even more input into that mean value. Thank y'all.